Hello guys, welcome back to my YouTube channel. It's been a while that I have not posted anything on YouTube, but I'm continuously posting YouTube shorts, not long videos. I was a little busy with other work, so I could not get time to upload long videos. Today let's get in. In this video also I'm continuing the part of load calculation that I left. Let's start it today. I think in last videos, last two three videos, I have covered around 7 subtopics under load calculation. Then it's 18th topic today, that is about distribution design. Mainly it includes how you size the dB. It totally depends on the size of an incomer, the outgoings, how many outgoings are there, then SPD, then you have to provide RCCB also for earth leakage protection, then it includes Busbar, neutral and earth link, metering. See, the dB size mainly depends on the outgoings and incomer size. Even if it is panel also, it will be same only. Usually the height, just look into dB only. The height will be around 300 mm only, or 450 mm it will be there. But the width and the depth is mainly depend on incomer and outgoings. Usually incomer will be either MCCB or MCB. So accordingly you have to select you will give the space for incomer. Then outgoings. Suppose if it is 3-phase, 12-way, not 12-way, 6-way dB. What it tells, 6-way means 6 into 3 R by B. Around 18 outgoings will be there. Out of 18, 6 for incomer only. That R and neutral, P and neutral, and Y and neutral. But along with outgoings, you have to check for RCCB also, and Busbar. Neutral earth link will be there, metering if required by the utility. This is about distribution load design. Then next topic is earthing system. It's a very important and critical topic in electrical system, because at the end, after installing our electrical installation, we need safety. So earthing system is for safety. So if you want in detail about earthing, I will give you an explanation in another video regarding earthing only. You might heard different types of earthing, that is pipe earthing, rod earthing and plate earthing. The main difference is pipe earthing and rod earthing are same only. Usually GI pipe and GI rod will be used for rod earthing and pipe earthing. But plate earthing, when we need very less resistance, and if system is of high voltage. So for high voltage application we use plate earthing. Why? Because you may know that R is equal to resistance is equal to rho into L divided by A. We need less resistance, so we have to R and A are inversely proportional. So if you want less resistance, you have to increase the area. Plate earthing will be having more surface area, so that we will get less resistance. So for high voltage application we use plate earthing, not pipe and rod earthing. For general purpose we use pipe earthing and rod earthing. Usually for general installation the resistance will be less than 5 ohm. For commercial it will be less than 2 ohm, and if it is critical and substation it must be less than 1 ohm. Then 20th topic is about short circuit calculation. Usually we load the circuit breaker or any breaker with a load current. So depending on the load, we will calculate the load current. We will size the breakers on that load. But usually we have to check for short circuit also. Short circuit means in very less time a huge surge will be there, huge amount of voltage will be there, huge amount of current will be there. So this is short circuit. For this also I will I'm planning to make a separate video on short circuit, how to calculate short circuit, and on that basis how to select the cable and all. I will give you a separate video. But let's see in simple that ISC will be the formula for short circuit will be √3 into V into 1000. 1000 will be for, usually we take voltage in kilowatts, so it is multiplied with 1000 divided by 2 is line and neutral, then into 10⁻³ into Z. Okay, this is for formula. You already know. This is formula. Then voltage, line voltage will be, we require only V and Z. Simple, it's simple formula. Like current, how do you calculate current? V divided by Z, right? So you require V and Z. V will be system voltage, that line voltage. For 3 phase it will be 415, for single phase it will be 230. Then Z you require, right? Total impedance. It includes the impedance of source as well as impedance of cables. Then you got all the things. You will just calculate using formula. Then you have to check whether it is withstanding with the equipment or not. It should withstand. Dynamic withstand also you should check. Use ISC to select. That I told you, no? There is a separate formula and separate ISC is there, that we can discuss later. Then 21st topic is voltage drop check example. See here, just I have given one example, whether your cable is below the cable, or whether your system is having voltage drop below the range, under the given ranges or not. For lighting it should be less than or equal to 3%. For power it should be less than or equal to 5%. Suppose see the load here, it is 40 kilowatt. It's not, obviously it is not an lighting load, it will be an power load only. Power factor is 0.9. So the cable size, the cable you are going to select for this load is 4 core 16 square mm copper. Then length is 60 meter. Its resistance, the cable resistance is 1.15 ohm per kilometer, right? See, the length is in meter and the voltage, the resistance of the cable is in ohm per kilometer. So please careful while calculating the voltage drop. Then voltage drop formula is simple. So voltage drop formula is simple, that I have already told you, √3 into I into R into L divided by 1000. Right? Just a second, give me a second to recalculate this value whether it is correct or not. Yes, I into R into I, you will calculate from this one, I into R into L. Yeah, the voltage you got around 7.41. So for percentage, 7.41 divided by 415 into 100, it's 1.78. It's like below the range only, it's within the range, so the cable selection is okay for this one. Then 22nd topic is firefighting load. How much will be the load for firefighting? We already know we have to take 100% for firefighting, 100% for firefighting, right? So that 100% or what and all is included in firefighting. Usually there are pipes, like different types of pipe: jockey pump, fire pump, diesel engine pump, pressurization fan, smoke exhaust fan, fire alarm panel. Okay. So fire pump will be, main pump will be 15 or 150 kilowatts. It will be of this range. Jockey pump is very small, so it will be below 5 kilowatt only. Diesel engine pump is same as fire pump only, 22 to 100 kilowatt. Then pressurization fan, it's 3 to 30 kilowatt. Smoke exhaust fan, 5 to 50 kilowatt. Fire alarm will be 50 to 200. It's very less of the fire alarm pan. Only control cables will be there, so that's why. This is all about today's class. So let's continue the same thing in next video. I'm gonna end this topic, that electrical load calculation for MEP design, in next video. So please make sure you are subscribed to my YouTube channel and give us like, share, comment to the video, so that I will also get motivated to do more videos. That's all. Thank you one and all. Bye.